Okay, Algebra 1, we are doing section 3.3, solving inequalities by multiplying or dividing. When you solve by multiplying or dividing, you solve just like we do with regular equations. And so you locate your variable. You ask yourself, what is happening to our variable? It's being multiplied by 3, so you need to divide by 3. X is greater than, negative divided by a positive is a negative, 27 divided by 3 is 9. Graph, negative 9, open circle, negative 11. Okay, X is greater than negative 9, so I shade to the right. Number 2, whenever we have a fraction, instead of dividing by the fraction, the best way to get rid of it is to multiply by the fraction. Skip, flip, and multiply. R is less than. This gives you 18 over 2. R is less than 9. 9, 10, 8. Open circle, less than goes to the left. Next one, Q is being divided by 5, or multiplied by 5, so you divide by 5. Negative 50 divided by positive 5 is a negative 10. This is one where the variable's on the other side. Who's bigger though? The 10 is bigger. This one is smaller. Close circle on my 10 because it includes the 10. Q is less than. And this one, I multiply by a 4/3. These cancel out. You have G is less than or equal to, I'm going to put that 27 over 1. Now, right here, I'm going to cross simplify because I don't want to take 27 times 4. I know that 3 can go into 3 one time and 3 can go into 27 9 times. That gives me 9 times 4, which is 36. 1 times 1, which is 1. This simplifies to G is less than or equal to 36. Start with your 36. 37, 35. I'm going to do a closed circle on 36 because it includes 36. G is less than 36, so the numbers that are less than go to the left. Okay, so when you are multiplying or dividing to get the variable by itself, it's pretty much the same way as we do equations, except when we multiply or divide by a negative number. This is where things change. So when you multiply or divide by a negative number, you have to flip your inequality symbol. So it's not super hard, you just have to remember to do it, which is where most of us make the mistake. So right away, we are dividing by a negative 8. So that means X, we have to flip our symbol. Positive divided by a negative gives us a negative. 72 divided by 8 gives us 9. Okay, and then we graph like we do before. Go to your number line, negative 9, negative 10, negative 8. Open circle, X is less than. Okay. This one, I'm just going to rewrite this so you guys can see it. Negative 3 less than or equal to X divided by a negative 5. X is being divided by a negative, so we need to multiply by a negative 5. This cancels. Negative times a negative is a positive 15. Flip your sign. 15 goes right there. X is smaller than 15, so that would be 14. Close circle. And anytime you want to check these answers, you could take a number off the side where you shaded. If you put 14 in here, would it make it true? And it does. 14 is smaller than 15. The next one, remember if we have a variable and there's nothing else there, it's a negative 1x. So we are going to divide by a negative 1. What happens here? 10 divided by a negative 1 is a negative 10. Flip your sign. We have x by itself. So a negative 10, negative 9, negative 11. We have a closed circle on negative 10. X is on the greater side of things, so it goes to the right. So it should have these little arrows on there. Okay. Last type of problem that you guys will see are word problems. It says Ryan has a $16 gift card for a health store where a smoothie costs $2.50 with tax. What are the possible numbers of smoothies that Ryan can buy? Well, each smoothie costs $2.50. So I would multiply that times the number of smoothies I buy. He has a $16 gift card. Can he spend more than $16? No. Can he spend exactly $16? Yes. So this total has to be less than or equal to 16. So when I solve this, divide both sides by 250. And if I take 16 divided by 2.5, I get 6.4. Can I get a partial smoothie? No. So I can buy, or Ryan can buy 6 smoothies or less. So 0, 1, 2, 3, 4, 5, 6 smoothies. The reason I listed them out was because we can't have partials, so we can't have decimals, we can't have fractions. We need to have whole numbers for our smoothies. Okay, the next one. A pitcher holds 128 ounces of juice. What are the possible number of 10-ounce servings, oh, sorry, misspell there, that one pitcher can fill? So we are going to get 10 ounces times every serving, but this has to be limited by the amount that that pitcher can hold. So can this total be more than 128? No, it has to be less than, but can it be equal to? Yes. Divide both sides by 10. We get 12.8. Okay, what are the possible numbers of 10-ounce servings? We don't want 12.8 ounce or 12.8 servings. We want to know how many numbers of 10-ounce servings. So we could have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 servings. Now, if this was like through 100, you could definitely do like 0 to 12 servings. But I do want you to know that we are limited. Like we can't have negative servings, we can't have partial servings. So make sure to consider that when you're doing your problems.